For this problem, we are trying to find the separable equation, differential equation, and we have a particular solution we're going to find with the given initial conditions. So I know that we're used to trying to break it up into something and divide it out. We don't see that here. The way I approach the problem, there are a couple of ways to go about this, but I was looking at this as dx dt equals, and then I combine these two terms. So it's 25x squared over 25 plus 1 over 25 gives me 25x squared plus 1 all over 25. Now, the idea is that we want to now bring over at least the numerator because it contains the variable term that we're after. And so the way we go about this next step, we just want to say there's some intuition involved here. For example, I'm looking at this as I can see where this might be going, 5x quantity squared plus 1 squared, and how that's going to be in the denominator. And when I do that, I might think of this as instead a 5x squared plus 1 squared over 5 times 1 over 5. So again, thinking ahead what might be happening, knowing that this numerator is going to become a denominator. And then I have an arctangent function. So that's why I might want to keep this 5, because if my u becomes a 5x, my du would need to have a 5 with it here. You don't have to do that. You could instead just bring over that numerator as a denominator and then do some substitutions and things work out. They cancel that way. For example, well, let me just go forward with how I want to do it. And I have my dx over dt equals 5x quantity squared plus 1 squared over 5 times 1/5. I'm going to multiply both sides by, go to red, by 5 over 5x quantity squared plus 1 squared, and 5 over 5x quantity squared plus 1 squared. And then this would have the 5's cancel there, this term cancel there, that expression cancel there, excuse me. So, and then I'm also going to multiply dt on each side. So these go away. And what that gives me on the left side is 5 over 5x squared plus 1, 5x quantity squared plus 1 squared, dx equals 1 over 5 dt. And if I were to integrate these, I'll have the integral of 5 over 5x squared plus 1 dx equals integral, and you can just put the 1/5 on here, dt, like that. Now if I said u equals the 5x, my du is going to be 5 dx. So we have the 5 dx here. So we could say then integral of 1 over u squared plus 1 squared du equals 1/5 of t plus, I'm going to call it c1. So over here on the left, this is going to become tangent inverse or arctangent of u plus some c2 equals 1/5 t plus c1. Then I will subtract c2 from each side. These are just constants. I mean, you can keep calling them whatever you want, but eventually we'll have just the one constant, and we'll find out what that is when we apply the initial conditions. Oh, I'm already at the bottom of this page. So we have tangent inverse of u. Well, why don't I go back to what it was, substitute back, tangent inverse of 5x equals 1/5 t plus just some c at this point. So now the idea is we're still trying to solve for this x. X is our function name, that's our dependent variable. which I know is unusual. Usually the x is the independent variable. So if I take the tangent of both sides, or if I use the definition of an arctangent, we would have 5x equals tangent of t over 5, or 1/5 t, plus the c, and we can divide both sides by 5. So our x equals tangent of t over 5 plus c, and that whole expression divided by 5. So how do we get the c? Well, we apply initial conditions. X of 0 is going to be tangent of 0 over 5 plus c all over 5, and that's going to equal -5 from our initial conditions. So that tangent of c over 5 is -5. So the tangent of c must be -25. So c would be tangent inverse of -25. And make sure your calculator's in radian mode, not degrees. You get c to be -1.530. That's a 5. 0.81764. So your function is going to be, I should say, x of t is tangent of t divided by 5, or 1/5 t, minus 1.53081764, all divided by 5. Okay, hope that makes sense.